Good day, everyone. Today I'll be going to discuss anything about logarithm, presented by yours truly, Engineer Chris Lynch, C. Denire. Now let's talk about logarithm. So when you see logarithm, it was discovered or first conceived by Just Berge. So he's a clockmaker in the employ of Duke of Hesse Castle. So here, this is the photo of Just Berge. He was born in 1552 and died in 1632. So he discovered the Napierian logarithm or natural logarithm or LN. So when you say LN, it's base E. Now here, this is the photo of John Napier. He was born in 1550 and he died in 1617. So here he discovered the Briggshaw logarithm or log. So when you say log, this is base 10. Alright, let's talk about logarithmic function. When you say logarithmic function, it takes a form of this. So we have f of x is equal to log x base a, where a should not be equal to 1 and a should be greater than 0. So let's say we have f of x is equal to log x base b, and this is equal to y. Then it is equivalent to an exponential form na x is equal to b raised to y. So this means that exponential function and logarithmic function are inverse of each other. Let's talk about the properties of logarithmic function. So these are the properties of logarithmic function. First, the domain. The domain of the logarithmic function is from 0, so from 0 to positive infinity. So when you say domain, it means the values in terms of x. So from here to positive infinity, we don't know where it stops. So next is the range. So it means the value in terms of x or our ordinates. So our range is from negative infinity, from here to positive infinity. So sa x-intercept niya is 0 and 1. And take note that logarithmic function is always increasing. Pa-increase yan ang value niya. It's 1 to 1, therefore has an inverse function, which is the exponential function. So next, y-axis is vertical asymptote. So it means as log x base a approaches negative infinity, as x approaches positive. So it is continuous reflection of the graph x equals to ax about the line y is equal to x. So again, logarithmic function, kabaliktaran siya sa imuhang exponential function. So kung y-axis is a vertical asymptote for logarithmic function, x-axis for exponential function, mauna ang ihang asymptote. So x-axis for exponential, y for logarithmic in terms of its asymptote. So it means di dyan na siya mag-touch sa y-axis pag logarithmic. Pag exponential, di dyan siya mag-touch sa x-axis. Right? Now, the expression of log x base b refers to the power to be which b must be raised to obtain x. Thus, b must always be a positive real numbers. So again, I already discussed this. You can convert your logarithmic function to an exponential function. So if we have this, log x base b is equal to y. So now we could raise b or our base to y, then it is equals to x. So the common logarithmic of any number is composed of a whole number or characteristic and a decimal or the mantissa. So the decimal power, or the power of our decimal value. So these are the laws of and properties of logarithms. So you need to be familiar with these, and I don't really suggest that you will memorize it, but you need to be familiar with this, and you can be familiar with this by practicing some problems. So let's start with log xy base b is equal to log x base b plus log y base b. So if you have this um, logarithmic function, so it means you will add log x base b plus log y base b. If you have division naman, log x over y base b, you will subtract. So subtract your upper function, which is x over y. So log x base b minus log y base b. Here we have log x raised to r base b is equal to log is equal to r log x base b. So kani pwede na nimo mapababa dere. Alright? Mapababa sa exponent. Now, let's move on to log x base b is equal to log x over log b. Right? Log x, kani log x, then log b. Here, if we have log 1 base b, that is equals to 0. If we have log b base b, that's equal to 1. When you say log b, or the base, log b base e is equal to ln e. Then if we have x is equal to 10 log, x is equal to 10 raised to log x, and x equals to b raised to log b x. And we have x is equal to e raised to ln x. So maybe let's have some example to further. Now let's have these examples to further understand logarithmic functions. So let's try to convert this exponential function to logarithmic form. So according to what we have discussed kanina, log base b is log x base b equals to y. So if you try to convert it in exponential form, this is equal to x is equal to b raised to y, right? So here, if we will transform this, this is our base, this is our y, right? And this is equal to x, right? If kani atong tanawon. So if we try to transform it into logarithmic form, this is equal to log base natin is 3. Then yung variable here should be the x, which is our y here, equal to x. Okay? Now, how about this one? Our base here is a, so log base a, then this is 2 is equal to b. Right? Now, how about this one? This is equal to log base 5. Then we have c is equal to x plus 1. Alright? Dali lang siya. Yan na lang siya. So, you can box your final answers. But that's fine with me if you didn't box. So, let's move on. Here, let's try to have logarithmic function and convert it to exponential function. So we have a, b, c. So let's start with a. Log 1/3 base u is equal to 2. So this is equal to u raised to 2 is equal to 1/3. Then for b, we have log quantity 2x minus 3 base 3 is equal to y. So we have 3 raised to y is equals to 2x minus 3. Here we have log 100 is equal to 2. So it is understandable that log has base 10. So this is equal to 10 raised to 2 is equal to 100. Now let's solve for the unknown. Let's start with a. So a, we have log 27 base b equals to 3. So with this, we cannot directly input it to our calculator, or we can already know the value of b. So by this, we need to convert it to an exponential form. So this is equal to b raised to 3 equals to 27. So we need to get the cube root of each term or each side. This is equal to b equals to cube root of 27, that's 3. So this is the unknown. So let's have log x base 25 is equal to negative 1 half. So again, same as with letter A, we are not allowed to get the value of x immediately by inputting it in our calculator. So we need to transform it into the exponential form. So this is equal to 25 raised to negative 1 half is equals to x. So x now is equal to 1 over 25 kasi negative yung exponent. We could baba that, and this is raised to 1 half equals to 1 over square root of 25. Then this is equal to 1 over 5. Final answer. Here we have 3 raised to 7x plus 1 equals to 6561. Again, we cannot directly input this to our calculator, so we need to transform this exponential value to logarithmic form. So this is equal to log 6561 base 3 equals to 7x plus 1. So if we try to input these values at ang left side, this is log 6561 base 3. This is equal to 8. So try to input this in your calculator. 8 equals to 7x plus 1. So we could transpose 1. We have 7x. We have 7 is equal to 7x. Divide both sides by 7. 7. So our x value is equals to 1. Right? So now let's move on to number 4. Let's try to expand the following logarithmic function using our laws and properties of logarithmic function. Now let's start with letter A. We have log x times x minus 1, plus 1. So with this, we can see that we have a product. So according to our law, it means you will add it. So we have log x plus log x plus 1. Right? This is how you expand this. Now let's have number 2. We have log quantity x minus 1 quantity raised to 4 over x plus 2 base 3. So we have a fraction form here. So this is subtraction. So we have log x minus 1 raised to 4 base 3 minus log x plus 2. I mean, this is quantity base 3. So as you can see in the first term, na siya exponent. So according to the law, we could baba that. So we have 4 log x minus 1 base 3 minus log x plus 2 base 3. So this is the final answer of your expansion for this logarithmic function. Now let's move on to the next one. Let us move on to natural logarithmic function. So these are the properties of natural logarithmic functions or natural logarithms. So we need to be familiar with this. So let's start with the first one. If we have ln of 1 is equals to 0 because according to what I've discussed kanina, ln is base e. So if we have e raised to 0 is equal to 1 if we will try to convert it in an exponential form. So a number raised to 0 is equals to 1. Now here, if we have ln of e is equals to 1 because if we will try to convert it in an exponential form, this is e raised to 1 is equals to e. Now here, let's move on to the third one. Ln of e raised to x is still equals to x, and e raised to ln x is equals to x. That's the inverse properties. Now, if ln of x is equal to ln of y, then x is equals to y. So that's one-to-one property. Okay? Now, let's move on. So let's talk about laws on natural logarithms. So let's say we have n as a real numbers, u, v are positive real numbers, and these are the following should be true. So in same as with your logarithms, same properties lang siya as well as in your natural logarithms. So the difference is you will use ln instead of log. So we have product property. If we have ln of uv, same thing with your log, you will add. So one term and another plus another term. So that's ln u plus ln v. If we have property for the division property, this is ln of u over v. Pag division, you will subtract each term. So ln u minus ln v. So if we have power property, same as with your logarithm. So if we have ln u raised to n, ibaba lang si n, sa in front of ln, that's n ln u. So change of base formula. So this is very helpful pag lahi-lahi na ang base sa inyong log or natural logarithm. So let's have a and b are positive real numbers such that a should not be equal to 1, same as b should not be equal to 1. Then if we have log x base a can be converted to a different possible ways. So if we have base b, so this is how you will do it. So log x base a is equal to log x base b over log a base b. Right, you just simply copy the base and then change it by using x as your numerator or the variable of your numerator, and then a will be the variable of your denominator. If you will try to change it in base 10, so if you have log x base a is equal to log x over log a, because it is understood now if we have log, it is base 10 already. So if we have base raised to e, of course, you will put it base raised to e, which is ln. So here we have log x base a, which is now equal to ln x over ln a, right? So logarithmic and exponential equation. So the strategies for solving logarithmic and exponential equation, first you need to rewrite the original equation in a form that allows us to have one-to-one properties of exponential or logarithmic functions. Next, if you will try to rewrite an exponential equation in a logarithmic form and apply the inverse property of a logarithmic functions. Now you will rewrite a logarithmic equation in exponential form and apply the inverse property of exponential function. I think we did this already in the previous examples. Let's try to solve for the unknown. Given that we have 50 minus 3 ln x equals to 4, we need to isolate the unknown. So we have negative 3 ln x is equal to 4 minus 50. So this is equal to negative 3 ln x is equal to negative 46 over negative 3 over negative 3. This is equal to ln x equals to 46 over 3. Then we already know that ln x is equal to e raised to ln x, e raised to 4x over 3. We try to change the base. So this is equal to, this is on the reverse property. So this is equal to, the inverse property, this is equal to x. And we have e raised to 46 over 3. If we try to input this in our calculator, the x value now is, we try to input e raised to 46 over 3. This is equal to 4 million, approximately 4,562,281.263. This is the final answer. So if we have this given, log 3x minus 2 base 5 is equal to log 2x plus 5 base 5. So here, as you can see, they have the same base. So we can simply write it as 3x minus 2 is equal to 2x plus 5. So we need to manipulate the similar terms, which is 2x and 3x, and negative 2 and 5. So we need to combine like terms. So we have 3x minus 2x is equal to 5 plus 2. So we could simply combine it. This is equal to x is equals to 7. This is the final answer. I think this is the end of my video discussion for today. So I hope you will practice solving and please review your modules for these topics. So maybe later on I will just give you some activities. Have a great day. Enjoy.